I'll first rewrite the sine cubed x as sine x multiplied by sine squared x. That's useful because the sine squared x, using the identity sine squared x plus cos squared x is 1, we can rewrite the sine squared x as 1 minus cos squared x. We can then expand out this bracket. We end up with sine x minus sine x cos squared x. And now we can integrate each of these terms. So the sine x just becomes minus cos x. To integrate what we have here, we have to first realize that this is of the form of f dash x multiplied by f of x to the power of n. And when we have something of that form, our solution would be of the form of f of x to the power of n plus 1. So raise the power by 1. In our case, the f of x is cos x, and the f dash x is the differential of f of x. F of x is cos x. This should therefore be minus sine x, which is what we have here. We have minus sine x. Though if we had plus, that would be fine as well. We can correct for that with what factor we put in front of our f of x to the power of n plus 1. So if we are integrating, so I'll put this on the right hand side, if we're integrating minus sine x times cos squared x, then our trial solution would be y is equal to cos cubed x. Differentiate this, so use the chain rule with u is equal to cos x. This differentiates to make 3u squared. This differentiates to make minus sine x, and then times the two things together, we get minus 3 sine x times u squared, where u is cos x. And what we have here, so remember what we want to have is this to differentiate to make this. Right now it's differentiating to make something that's 3 times bigger. So we multiply this by a third. That carries through, that factor of a third carries through to the end, which will then cancel with the 3. And now this is differentiating to make what we have here. Therefore this integrates to make this. So add on a third of cos cubed x and a plus c, and there is our final answer.